Good morning, everyone. Today's topic is types of system. So, let us discuss what are various types of systems. Whenever we are talking about the concept of the system, this is the main these are the main components of a system. We give any of the system one input, and then there is processing, and then there is the output. Now, depending upon the output we get, we take the feedback from the boundaries and the external interfaces, and depending upon the feedback we try to mold the inputs so that our feedback always remains positive. So in any system a control environment is also important, because in control environment if there are certain deviations or maybe the system is not working appropriately, then the control has to be incorporated. Now, talking about the elements of the system, input is what we feed into the system. Processor is what takes input as a data and then processes it and gives us the information as an output. Then comes the feedback. Feedback basically provides the control in the dynamic system. Since the system is dynamic because it is interacting with the external environment mostly, so the feedback plays a very crucial role. Positive feedback is routine in nature that encourages the performance of the system, whereas if we talk about a negative feedback, it is informational in nature. Why? Because it tells the controller that some action is required to be taken in order to put back the things in place. Then is the environment. Environment basically is the super system within which the organization works or operates. Any organization cannot work in isolation. So it works within a bigger environment from which it regularly interacts or maybe takes the input or gives the output. So it is the source of external elements that strike on the system. Now, elements of the system, basically in this it determines how system must function. For example, the vendors, competitors of the organization's environment may provide constraints that affect the actual performance of the business. Now, talking about the boundaries and the interfaces of the system, a system should always be defined by its boundaries. So, boundaries basically are what? These are the limits that identify its components, processes, and the interrelationships between the interfaces with the other interfaces that are residing there in other systems. So each system has boundaries that determine its sphere of influence and tries to control the environment. So the knowledge of the boundaries of a given system plays a very crucial role in determining the nature of its interface with other systems for a successful design. Now there are various types of systems in MIS. One is open system, closed system, deterministic, probabilistic, abstract, and physical systems. N number of systems are there that plays an important role. So let's go through them one by one. Now what is an open system? Open system is one that interacts with the environment and exchanges the information, material or energy with the environment, including random and undefined inputs. So it regularly interacts with the external environment, fine, and it is an open system. The name itself tells you. So the other system can also interact with this system. So there is a regular interaction, maybe the exchange of inputs and outputs with other systems in an open system. So these systems are adaptive in nature, as they tend to react with the environment so as to favor their continued existence. These are self-organizing, and in the sense that they change their organization in response to changing their conditions. So there is continuous interaction with the environment in an open system. The information can be exchanged, and if we talk the material, energy in the production, manufacturing industry, so energy, material, everything can be exchanged in the external environment. So it is open in nature and self-organizing. It is also adaptive to the changing environment and it is flexible too. Now, opposite to the open system is the closed system. It is one in which there is minimal or no interaction with the external environment, and in the business world, such systems are very rare. Thus, the systems that are relatively isolated from the environment but not completely closed are known as closed system. So, they do not have very much regular interaction with the external environment, but yes, they can also not exist in isolation, but very minimal interaction is there. So, these systems generally exist in concept only. In practical nature, if we talk about business organizations, these systems do not exist as they are very rigid in nature. Now, it is not at all amenable to the change. It is self-contained and isolated in nature. It is having a well-defined boundary and it is not at all adaptive in nature. So, it is very rigid, not at all adaptive in nature. Once you have built it, you have to work according to that only. Next system is deterministic system. What it is, the name itself tells you, it is one in which the occurrence of all the events are previously known with certainty. We are certain about the occurrence of the event. So, deterministic, we are determined that yes, this is how the system is going to work. In such systems, the interaction of the element is known, and as the behavior of the elements is predetermined, so it becomes very much possible to work upon the reaction well in advance. So, in advance you can work upon the reactions. It is a system in which a given initial state or condition will always produce the same result. Because it is deterministic, so randomness and variation in the ways that inputs get delivered is very less. If the description of the system state at a particular point of time of its operation is given, so the next state can be perfectly predicted. So, if previous state is determined and we all know what is there in the previous state, then the next state can also be predicted very easily. Now, it is a system in which the later states of the system follow from or are determined by the earlier ones. Now, moving on to the probabilistic systems, the opposite of deterministic systems. In these systems, the occurrence of events cannot be perfectly predicted as we did in the deterministic system. Though the behavior of such a system can be described in terms of probability, a certain degree of error is always attached to the prediction of the behavior. Now, it is based on the predictability of the behavior or the outcome. So, totally probabilistic system is based on the predictability of the behavior or the outcome. It is one where the output from the system behaves probabilistically, that is, the output is predictable according to the probability values. The portfolio investment system of an asset management company that generally invests in the stock market will have a probabilistic output for a given input because there is a probability of change in it. You cannot predict each and every accurate value in that particular system. Next set of systems are abstract systems. An abstract or conceptual system is an orderly arrangement of interdependent ideas or constructs which may or may not have any counterpart. So, these are conceptual in nature and they do not have any physical entities. So, they can be in the form of formulas, models, concepts, representations and so on, and these are theoretical and explanatory in nature. So, it provides the much needed clarification. Now comes the abstract system. It provides theoretical framework for which there may or may not be any real life counterpart. For example, philosophy, theology. So, continuing with the abstract or the conceptual systems, so philosophy, theology, all these comes under the abstract system. So it is an ordered management of concepts, and it can be procedural or conceptual. Next is physical system. So it is empirical in nature. These are generally concrete operational systems made up of people, material, machines, energy, and other physical things. So these are very practical, specific, and also very operational in nature. So it can be based on the conceptual system. So any examination system, surgery, and so on are the examples of the empirical or physical systems. These are tangible entities. It can be static or dynamic in nature. Any system like computer center is also one of the physical system, arrangement of desks, chairs, and so on with the static parts are concepts of physical system. The approach stands on the assumption that breaking down of a complex system into simple, easy to understand units helps in better understanding and managing the systems. So it attempts to understand the role each component plays in the system. So major components of the system approach are holism, that means a change in any part, component of a system that affects the whole system either directly or indirectly. Then comes specialization. In a system, basically it can be divided into granular or smaller, easy to implement parts or components, so that the specialized role of each and every component can be appreciated and managed easily. Then systems are non-summational, that means every component is of importance to the whole system. It is therefore essential to understand the actions of each component to get the holistic perspective. Then comes grouping. The process of specialization can create its own complexity by proliferating components with increasing specialization. So generally, to avoid this, it becomes essential to group the related disciplines or the subdisciplines. Next comes the coordinations among the system. So basically the group of components or the subcomponents, they require coordination in order to work for a particular goal, and without coordination the components will not be able to work in a concerted manner and might lead to chaos. So coordination and control is a very important concept in the study of system. Then comes emergent properties. Again, it is also one of the important concept of the systems approach. It means that the group of interrelated entities having properties that are not present in any individual component can be working together in order to achieve a common goal of the system. So this is the holistic view of the system. For example, multicellular organisms exhibit characteristics as a whole which are not present in individual constituent parts like cells. So emergent properties, certain components have the properties that must be combined together for the successful functioning of a proper system. So with this we finish off with the concepts of the system. Each and every system plays a crucial role and may be divided into various components, and these components work together in order to achieve a particular goal or the objective of the system, and the feedback and the control component are very much essential for any of the systems to work in an effective manner. Thank you so much.